Hello, everyone. Welcome back. Our next speaker is Constance Martineau. Constance is a staff product manager at Astronomer and a longtime contributor to the Apache Airflow open source project, which has helped shape the features across Airflow 3. She works at the intersection of data engineering, orchestration, and developer experience, turning complex infrastructure into tools that feel intuitive and fun. When she's not working on new features, she's usually automating something else, like her coffee machine, her lights, or in this case, the on-air sign that knows when she's in a meeting, which is very neat. And without further ado, take it away, Constance.
Hi, everybody. So my name is Constance, and I'm a staff product manager at Astronomer. Before I get started, just out of curiosity, has anybody heard of Airflow in this room? Okay, so there's a good chunk of you. Fair enough. It's honestly, for these type of conferences, a hit or miss. So fair. Well, let's get going then. All right, so like I said, my name is Constance, and I am a staff product manager at Astronomer. So my job technically is to make Airflow better for the people who use it in production. But my job apparently these days is also to find the most absurd possible use cases for Airflow. So you're about to see evidence of that today. This is the first time I've tried HTML slides. It's wonderful to build, a little hard to control apparently. So basically, I work from home. I love working from home. It's fantastic. But the problem that I have, as you can see through my setup, is that whenever I'm on a Zoom call, nobody knows I'm actually on a Zoom call. So that means that my husband will come in and be like, do you want lunch or something when I'm talking to my CEO? My dogs will come in barking. And so a lot of times they would see me, mute and unmute myself all the time and kind of go look a little hectic. And of course, I have to be on camera, so I am. So at the end of the day, I decided that I was going to build a sign to let them know that when I'm on a Zoom call, they should not disturb me. And I could have probably done a Post-it note or something, but I'm a product manager at Astronomer, and I like using Airflow. So I decided to overcomplicate this and build the most absurd thing possible. So ultimately speaking, like I said, is that what I built is that I built an on-air sign that's powered by a Raspberry Pi Zero. So this is really like a $15 computer, which has less RAM than a Chrome tab. And it runs enterprise workflow orchestration software, basically just to change the color of some LEDs. Man, this is annoying. All right, so what is Apache Airflow? Like I said, Apache Airflow, for those of you guys who don't know it, is a Python native orchestration tool. So you can think of cron, but on steroids. So you write Python functions, you wire them into a DAG object, which is like a directed acyclic graph, and Airflow will handle the scheduling, monitoring, and logging for it. It has 40,000 stars on GitHub today, and it is the most popular open source orchestrator for data pipelines. This is basically what a very, very simple DAG looks like. So in this case, it's 3 tasks that were wired together, one to extract data, one to transform data, and one to load data. So typically, most of our users are data engineers using this for data orchestration workflows. But as you'll be able to see, you can really use it for anything. So typically, what we'll see a lot of times people doing is we'll see them doing things like extracting data into Snowflake, then taking a task and transforming it using dbt. Then they'll go ahead and maybe load that into BigQuery and then send some Slack alerts. This obviously works for, like I said, for data workflows that are typically running on the cloud. This also works for things that are running on servers or basically things that are on your network access. But what we started to wonder with Airflow 3 is, but what if the task you need to run isn't in the cloud, but is in some sort of locked up computer room, for example, in a data center? So this, like I said, this is the question that Airflow 3 started to question. So Airflow 3 shipped in 2025, and one of the most exciting features was the edge executor. So this is how essentially it works. You take, like I said, a package of Airflow, and you install it onto really almost anything like my Raspberry Pi. And what that worker will do is it's going to go pull the Airflow server essentially to check to see if it has any jobs to run. What's nice about this is that you don't really need to worry about inbound connections. You can put this behind a NAT. Really, it's actually quite simple and lightweight because all it's doing is pulling, like I said, the main Airflow server for jobs. So that means no Kafka, no RabbitMQ, no Kubernetes. Really, as long as your device can run an HTTP request, it can be run as an Airflow edge worker. The second piece as well that came with Airflow 3 was multi-executor routing. So for those of you who don't know what an executor is, it's basically the engine or the thing that is actually running your Airflow tasks. And in Airflow 2, really the expectation was that the infrastructure had to be uniform and Airflow would consider all workers essentially the same. But in Airflow 3, you can run a mix of executors, which means that you can run a mix of hardware all within the same Airflow, all controlled by the same DAG. So in our case, that means some tasks can run on your server, some tasks can run on your Pi, all of this in the same DAG, and all of this in the same DAG file. So let me show you how the pieces connect for this. So this is what I have set up. I basically, on my laptop, have my Airflow server, which is like my Airflow scheduler, my API server, and just basically the main Airflow components, as well as local executor, which is, again, just local workers running on a Docker container. I also have a script that's a zoom monitor.py, which I'll talk about in a little bit, but that's essentially the thing that is checking to see if my Zoom is running or not. I have an Airflow sensor that checks to see that controls that zoom monitor.py and basically checks to see, like, hey, is there a Zoom meeting happening? If so, start the process. On my Raspberry Pi, what I do is I have my edge worker that is over here, and essentially what that is doing is it's checking to see, it's waiting to see, can I run the job or not? And when it does see that it can, it'll write a JSON file, which is then picked up by my LED service. So I think as you'll see later when we talk about the DAG, is it's actually all really decoupled, and that was on purpose. But ultimately speaking, like I said, the edge worker is sitting on a different worker. It pulls the Airflow server to see is it time to run a task, and if it can, fantastic. I put this all behind Tailscale, just for static IP purposes, and because really conference Wi-Fi can be a bit of a hit or miss. So we'll see how that works out today. All right, and then this is the hardware. So what I have over here, and I have it on my desk as well, is I've got the Zoom, the LED monitor, which is a 64 by 32 RGB LED, and then my Raspberry Pi 02W. All of this house, so I have a bonnet, and to be honest, a bunch of things that I don't really know what they are because I am not actually an infrastructure person, but we will talk about that in a bit more detail as well. All right, so here is the demo portion. Bear with me a few moments while I get this up. For those of you guys who don't know, this is Airflow, and this is the workflow that we're going to be running. So the start of the DAG is that I'm going to be waiting for my meeting to start. Whenever that DAG starts, it's going to go ahead and it should set my thing on air. Then it'll wait until I leave the Zoom call, and then it'll set the status to free. Now, okay, this is actually the wrong way. I should have looked at this first. Apologies. Right now I've got it on PyCascades, like I said, because it's in an idle state. Forgive me for this as well, but because this was a little fast to set up, I actually have to check to make sure that, yep, the devices are there and it's running perfectly fine. So I'm just going to go ahead and get this all set up. Okay, just for if you guys want to go ahead and I'll show you. I'm just going to go throw my IDE onto over here as well. I'm assuming. Okay, well, that's not moving over, so that's not going to happen. Honestly, hardware demos are really, really tough. If I had to do this over again, this is really cool, but I'm not sure if I would do that. All right, everything is up and it's running. So what I'm going to do over here on my screen is I am going to start a Zoom meeting. Where is my Zoom meeting? All right, you guys, this is a little bit awkward right this second because my Zoom is not coming up. So I'm going to exit it and try this one more time. The irony about this is that we tried this like 5 minutes ago and it was absolutely fine. So of course, this is going to happen when I'm in the room. This is also running on my personal hotspot right this second. So, all right, guys, I apologize, but I don't know how much this is going to happen right this second for why my Zoom is not connecting. So what I did do, because I had a feeling something like this would happen, is I have a way to fake the Zoom call. So if you just give me a moment, I will do that. So what I'm doing is I'm actually, like I said, what my script would happen is that I would have a process that would go and would be watching for the Zoom process to be happening. Once the Zoom process was detected, it would go ahead and it would write a state file. Given that my Zoom is not behaving, I am just going to go and simulate that state file. And we should be, hopefully, at this point, seeing that it went on air. Yay! Having said that, this should actually be showing succeeded. And it is being a little difficult right this second. So I'm just going to go ahead and check. There we go. OK, well, I'm glad. There might have just been a timing issue. So yeah, I can go, my meeting started, it set it on air, and then now it's waiting for my meeting to end. As I said, I faked this, so I will now go and give the exit signal. Just give me a moment here. And great, it's not making me a liar. So, and now the meeting has ended, and now it says free. Thank you very much. Like I said, guys, hardware demos are not something I'm probably going to ever do again, but you seem like a fun crowd. All right, so like I said, so this is essentially what the workflow is. I promise I actually really do use this at home, and it has helped my life quite a bit. My husband doesn't work from home, but he is there quite a bit, especially on Fridays, and so it's been a very nice communication method. Like I said, some of the things with Airflow as well is that it will handle restarts, it will handle tries, and it gives you some observability. So if I go back to, let's say up over here, I'm just going to the grid view to show, is I can see my last few runs that were done and how long they took. I can also see if they failed and what the retries were. And I have logs, well, I have the code over here as well that I can go ahead and I can see. And I have some logs as well. So Airflow, like I said, is a powerful tool if you are into automating your workflows. That's the demo part, but I'm going to go into a little bit more about what we actually did after that. So this is the DAG itself, and I want to kind of highlight a few things that we did to make this all work. So the first thing is the schedule. So people sort of assume that Airflow is really just for batch jobs, and honestly, that is where it excels at. So typically, you think cron, you put a cron schedule. But what you can also do is you can set a continuous schedule, which has been around for probably about 1.5 years. And what that does is it essentially acts like an event loop that continues running. Each Zoom call, in my case, is like one loop. So once the DAG finishes, it restarts right again to watch for my next Zoom call. In this case as well is that I set it to max active 1 runs, because really I only have one Zoom meeting at a time. I wish I could clone myself and have 10, but I cannot. The DAG itself, right, is like I mentioned, is that it's wait for meeting to start, set on air, wait for meeting to end, and to set free. Now, if you understand Python, you can really follow along what this DAG actually does, because it is just Python up and down. The bit shift operators over here are what set the dependencies and basically let it know, run this one first, then run this one next, and then run this one next, and run this one last. This is a nice and simple, straight job, but you can get really complex with them. So how did I get it so that I was running part of my jobs on my laptop and part of my jobs on the edge worker? Well, I do that through the task. So the task sensor over here, this was the thing that would essentially be watching for the Zoom process. It's a nice simple one where it just basically sits there and watches, and it just checks if this path exists. If it exists, it says true, and if not, it says false. Once it says true, that's what kicks off the rest of the jobs. On my Pi, this is, like I said, my on-air, set my on-air and set on-air job. What makes it run on the Pi itself are these two keyword arguments over here. So the edge executor, which, like I said, is the lightweight executor we used, and then the queue. I can have one queue. I can have 25 million queues. It's really how I go ahead and I configure my environment. So the Zoom detection logic in and of itself, I really was going to go and try to set up, to do this, I want to say, properly by using the Zoom APIs and the webhook and everything like that. But then I realized I had to deal with OAuth scopes. And again, Wi-Fi around here was going to be a bit of a hit or miss. As we saw, I couldn't even connect to my Zoom just now. So I really went with simple as best in this case. So what I found out as I started coding this, or getting this process going, is that Zoom has something called the CPT host, at least on Mac OS. And so that thing is present when you're on a call, and it's gone when you're not. So again, just 4 lines of pgrep code and pgrep processes, and it could go ahead and it could detect the logic. So that seemed, like I said, a lot simpler than dealing with setting up Zoom scopes. So I did that in 5 minutes instead of hours. The other thing, too, is that I really wanted to make sure that I decoupled the tasks from the hardware itself, and I didn't want to start introducing complexity by bringing in messaging queues. So how I dealt with that is really just state files. So the Airflow task would write a JSON, like I said, when it detected the process, it would go ahead, it would write a file, whether it was the Zoom process or the LED state file on my Pi. And then the service itself would see the state file, and then it would know, based on that, what to do. So the LED library holds the GPIO while running. What I learned by that, what I mean by that is that if the Airflow task could actually try to drive the display, it would be a problem because it would never have the exit condition and it would never be able to move on. What would end up happening, and I tried it, is that the task will time out and then I have a broken LED screen. The big thing with Airflow is that tasks really should be ephemeral, so meaning every time I run a task, that task should be producing the same results, and that seemed the easiest way to achieve it through state files. So the long story short is that if your task can't finish because of reasons, just decouple that logic. So the design principles that I really try to stick to is that pull beats push for constrained environments. So at the end of the day, while this is just a little toy example, I do work with a lot of companies that have lockdown environments where really like networking access is almost nothing. And at the end, what really only seems to work for them is the ability for them to pull out. So meaning if you have to ask for open ports or VPN or get VPN access, it's not going to happen. So in my case over here, the Pi reaches out over HTTPS, which is nice and simple. This would work behind a NAT. It works, well, it should have worked on conference Wi-Fi. Nice and simple. And that brings me to my second point, is that simple will always be clever. I really did try to be clever because, you guys are all Python engineers or experienced with this, and I was in my previous life, but I'm not anymore, and I did want to impress you by that. But it really just turned into a problem. So in my case, again, I stuck with pgrep over the Zoom API. I decided flag files over Kafka. At the end of the day, though, the dumbest thing that works was, for me, really the most reliable thing, and so that's what I stuck with. Some practical realities that I ran into. We already covered the decoupling tasks from the resources they can't own, but I'm not going to sit here and lie to you and tell you that at this point in time, running Airflow on IoT devices is like really production grade. It's still a lot. So to get this working, I only had about 416 megabytes of usable RAM, so I did have to add some swap. I added about an extra 2 gigs for that to work, and it did. But ultimately speaking, we know that we need to build a much lighter runtime to be able to run on these really light devices, and so that's something that's happening as part of AIP16, and it's a known gap within the community. But again, this was a demo, not a production IoT, and it's really just to show what is possible at this point. So what else could you do? I mean, how we envision this working is that people can go ahead and add, start using Airflow to orchestrate IoT sensors in factories, for example, or greenhouse data, or inventory data from retail, for example. Home automation, look, it works, and I like automating everything with Airflow, but that is like my day job, so take that for what that is. But it can be used really well for the other cases, and as well as field data that might be network constrained. Really the point, though, is that workflows don't always live in the cloud, and they are in the real world, and we need a way to get to them, and this is essentially it. So if you guys want to see the demo, or if you want the demo code, that is the QR code for the GitHub repo, and it really has everything, so like my systemd files on how I set up the Pi, all the scripts. If you're interested in the the LED script as well, that's about 200 lines of Python that's listed there as well. So please go ahead and take a look at it. You should be able to find me as well through my GitHub, so if you do have any questions or any ideas, or you want to get a bit more involved in Airflow, please do reach out. We are looking always for contributors. I don't know if this was really 25 minutes, but I'm sure there's time for Q&A, so if anyone has any questions.
Thank you, Constance.